All right, hey everyone, and welcome back to our fourth lesson in the curriculum. Today, we are starting CAD. We're starting computer-aided design. Now, before we get started on this, because this is very important, but I need you all to know something, and that's that CAD and design are not the same thing. All right, so there's a very big distinction here, because a lot of people think, there's a misconception going around that if you are a good designer, you know CAD, right? Or if you know CAD, you're a good designer. Both of those are not true. I mean, they can be true, and a lot of times they are true. But sometimes, I know plenty of really successful engineers that design with a pen and graph paper. That's where I do most of my designs at first, and then I translate them into CAD. So CAD is a part of the process, right? It's a tool. It's like a pen and paper. It's a part of the process that helps you translate your design into a format that others can basically read, right? So CAD is a tool that helps you translate your design into a format others can read. And that helps you make your design better, right? Because the more input you have from other people, the more ability you have to have your design be successful and not really miss anything, right? Have your design be successful and not miss anything. And also, if you can see it in almost a physical format that CAD is able to show, you can catch a lot of finer details and you can really build a more detailed and sophisticated design. But CAD is not, you don't do design in CAD. I know, plenty of people who know CAD and still, can't design for shit. I mean, they're fantastic CAD users, or they're at least pretty good CAD users, but they don't know, basic design concepts. And that was me. Like back in, the off season last year, or when I joined the team, I was asked to design an intake mechanism for the off season competition. So I designed something, and theoretically, no, it didn't even work. It wasn't even close. And I didn't use any, sort of common off-the-shelf parts. It was completely just like, it looked more like a concept than design. And I was proficient in CAD. I was good at CAD, but I didn't have the context and the experience doing robotics design. So ultimately, my design was not successful. And that's just something that has to come through experience, going to competitions and seeing what kind of parts are used. But that's sort of the aim of this curriculum here, is to sort of give, a total picture of what first design, of what robotics design looks like and what practical design looks like, because having that picture really will help you to create designs using CAD, right? You create designs in your head, right? And then you use CAD to embody those designs. So a CAD is, again, it's just like a tool, like a pen and paper. But all right, now with that point out of the way, we'll go ahead and get started, right? So we're switching gears and talking about CAD today, right? It might be important or whatever. But the CAD software we use is Onshape. And it's an online CAD software, so no downloads are needed. It's also free for students, right? And it runs in browser. So we can run it on the school Chromebooks that we receive. And it's really useful because, first of all, it has online support. So you can run it on a potato of a machine as long as it has a fast Wi-Fi connection, which I often don't. So even though I have like a pretty decent laptop workstation, my internet connection is pretty slow, so often Onshape suffers. So there's trade-offs there, of course. But Onshape also has some really good collaboration features. It really does. I think Onshape is one of the best softwares for collaboration. It's right up there with Fusion 360 in that regard. And that's just because you can share your files. You don't need to do downloads and stuff, and you can have two people working on one document, one file at the same time, working on one design at the same time, which is really useful, and there's not many other CAD softwares that can do that. It also has intuitive features, so it's pretty easy to learn, and I think workflow-wise, it actually is very intuitive and very simple to use. But also I have quite a bit of experience in Onshape. I have more hours in Onshape than I have in Smash. So that tells you something, I guess. All right. So first things first, we're going to create an Onshape account. And now these are document instructions. They'll be linked in the description. Basically what you have to do, and we'll go over here, we'll go to this, and we'll go to onshape.com. Man, I really can't type today. We'll go to onshape.com. Wait for it to load. And here we go. All right. So going to onshape.com here. This may not, so you would go here, you go to sign in. and then I've got my my email will show there, and then you'll just go ahead and say create a new account, and you'll choose the education account. All right, you'll choose the education account, and you will have to. You can choose an education account or a maker account. I personally have an education account because you get a few more bells and whistles over the maker account. But yeah, so education account is generally going to give you what you want. All you have to do is input your graduation year, your school's name, and your school's website URL. If you don't have if you're like homeschooled or something, you can just use, you can either use a maker account or you can just use a Google, some sort of random website, I guess, like maybe an email address. But yeah, so next thing is we're going to talk about how to use Onshape, right? So in Onshape, and most computer-aided design softwares, right? Like once you know one CAD software, you know them all. There are definitely nuances, and there's definitely differences between how they work. But for the most part, it's the same few concepts, right? You have two-dimensional sketches, and then you can use those to create or modify parts, which is one thing. A two-dimensional sketch is just like a 2D sketch. It's flat. Then creating or modifying parts, and parts are three-dimensional, but it's one thing usually. And these parts, or no, it's always one thing. A part is one thing. And then these parts can be put into assemblies, which is a group of things. And assemblies are designed to mimic real life. So let's say you have a car, right? And your car is an assembly. That's going to be the full assembly. And then your wheel is going to be a part. Although in reality, the wheel is a sub-assembly, right? Because you have the tire, you have the rim, you have the lug nuts, you have the brake rotor. You have a lot of components on the wheel. But let's just call that a part, right? Or you could have your part be the wheel rim or the tire or your brake rotor, right? So these parts can then be put into assemblies, and in CAD, you would have all of those things in the assembly. And you put that assembly into the main assembly of the whole car, right? So an assembly is a system of parts that is constrained, right? So movement is constrained. So if you have something that rotates in real life, it would rotate in an assembly, just like a tire on a car. If you grabbed it and dragged it around in the assembly, it wouldn't move, it would just rotate like this. They can be put into assemblies, and then you can vary them. You can vary assemblies pretty wildly in size and complexity, but they're always going to be designed to mimic real life. That's the main aim of CAD, is to embody a product that you're going to be building or creating. Although you can just do CAD for fun, for something that you're not actually going to create, but even then you should make it feasible to actually make. So CAD designs, right, they represent real-world parts and assemblies and are used as guides for manufacturing and assembly. So in our case, our CAD represents what a robot will be when it's complete, and then we manufacture parts based off of the parts in the CAD, and then assemble mechanisms based off the mechanisms in the CAD, which will, if we do it right, if we do assembly right, our final robot will look exactly like our robot CAD. And sometimes there are modifications made, but usually if you make those modifications in real life, you will change the CAD to reflect that. You want to have an accurate CAD model to what you currently have at your disposal mechanically. So, designs in Onshape are contained in a document, right? And this is where Onshape starts to get different than other CAD softwares, is file management, because it's all stored in the cloud, so you don't have to worry about having your onboard file explorer in your computer be storing the file. It's really just, it's going to be in a document, which is in the cloud. And in a document, you can house as many parts and assemblies as you want, really. So you don't have to just house everything separately and then just have one folder. No, in one document is one design. So one document is one design, and that really helps unclutter things. I don't know why other CAD softwares aren't doing it that way. So a document houses all of the files, parts, and assemblies you need, and then you can create and modify. Right, so it houses all the files, parts, and assemblies you create and modify. So if you import something off the internet and modify that, it will be added to the document. So that's for a whole assembly, or actually just for a whole design, which usually a design will be a master assembly, which is usually comprised of other assemblies, called sub-assemblies, actually. So documents can be contained in folders, right, which can be organized if desired. I really love good file management. I don't know why. Like my Google Drive is just like a rat's nest. It's completely not managed at all. But my Onshape account is like folders upon subfolders upon subfolders. It's so beautiful. I just love it. And yeah, having really good file management also helps you find stuff and helps you iterate stuff. And so you can tell somebody, yeah, okay, go to the Onshape team, which is something that you can make in Onshape as a team, where one document that's posted in the team is shared with everybody on the team. So we have a team for a robotics team. Said the team a lot in that sentence, but yeah, we have a team for a robotics team that effectively lets us just share our documents and collaborate on them whenever we want. So this is where we're going to get into basic mouse controls, and I'll explain this when we actually get into CAD. So the first thing we're going to do, I'm going to open up my Onshape documents, and I've already opened up Onshape here, and we're going to go to our team, Team 4795, the eSpots, and now if you are on the team, just go ahead and send me, once you've made an education account, just DM me or email me the email that you use to create that account, and I will go ahead and add you to the team. But yeah, so we go in here, we go to 4795 eSpots CAD, and then we'll go to this folder, Off-Season 2020. You see what I'm talking about file management. And now we've got all these different subfolders. So the one we're going to be going to is, actually first we'll go to team member folders, right? And that's where you're going to be putting your folder, right, with your name. So we'll go there and then we'll go back to there. But you'll go ahead and go up to this tab here and say create, and you'll make a folder and you'll name it your name. Right, you'll name it your name. Name it your name, like that. And we're not gonna cancel that. We're gonna cancel that, but then you'll just go ahead and drag that into Kit Design, and that's where you will put all of the documents that you will be making in CAD during this series. We'll go up here to Presented Practice Documents. And you can see we've got a few documents that we will be looking at go ahead and move that there. Just want to keep all the original copies in here. So got these presented practice documents, right? And basically this is just going through the list of things that we will be working with. And now I think the original first part document is not in here, so we'll go ahead and make one. Move that to there as well. All right, so first thing we're going to do, go to this folder, and actually what you will do is make a copy of the one that's already there, or just make your own document. But I'm going to go create and create document, and I'm going to call this first part. All right, I'm going to call this first part. See here, it's going to, as soon as we title that document, it's going to open it up. And now, here's where we get into navigating CAD and navigating Onshape. So we're going to be doing, right, you have this 3D viewer, this graphics area, and when you're using CAD, spoiler alert, it's really helpful to use a mouse. I don't know if that's a spoiler alert, but it is a helpful tip, because then you can right-click and drag much more effectively in order to orbit like this, right? This is me right-clicking and dragging. Then you can also right-click on different locations in order to get different, different options based on the context of where you click. And you can also middle-click with the scroll wheel to drag this around, to pan. And then you can also zoom in, or zoom out, and then zoom in. And I actually have my scroll wheel flipped to mirror SolidWorks, but really, it doesn't matter. So you can zoom out, and you can zoom in like this, right? And then you can also left-click to select. You can select multiple things without having to press any sort of control, right? Left-click to select, and then click the background to deselect, or press Escape. And then you can also left-click and drag to the left to do this type of highlight, and then left-click and drag to the right to do this type of highlight. And we'll get into the difference of what those highlights do in a later episode. But yeah, so you can left-click and drag to highlight, and that's basically it, right? You're ready to navigate CAD. You can also look at this little thing here, and that will show you different views if you click on the box. You can't drag it around like you can in Inventor. If you do, it just moves. But yeah, so like if you're making a sketch, on the top plane here, you'll click the top of this box. That way you can always view normal to it. So yeah. But speaking of sketch, right? Actually, we'll do a sketch in a second. Let me show you what these are. So here we have Part Studio 1 and Assembly 1. Now, in Onshape, you make parts in Part Studios, and you can actually make multiple parts in one Part Studio if you would like. We won't really get into doing that, but it is something that you can do, and workflow-wise, it's actually really useful because you can, visualize things without having to assemble them. You can literally build them right there. You can also do that in Assemblies, but doing it in Part Studios allows you to have fewer files and sort of just manage everything a little bit more nicely. But if we go to Assembly 1 here, you can see it looks basically the same except you don't have those three planes. And assemblies are just groups of parts. We're not going to be making an assembly today, so we're going to right-click on this and say delete. But we got right-click here, right? We've got this Part Studio here. We'll rename it, and I like to name things in Onshape. I mean, you got to name you really want to name all the tabs just so you can find stuff, but you can also name sketches or planes or anything you make in Onshape, which is really useful. But I'll name this first, man, I really cannot spell for my life, part. All right, first part. And then we're going to click on sketch, right? So the first thing we're going to do is make a sketch, which is two-dimensional. And then we'll use these surfacing tools to turn it into a three-dimensional object. So first we're going to make a sketch, right? You can say Shift-S if you're a gamer, or you can just click on the button up here if you're, an ordinary citizen of the country. So, yeah, top plane here, we'll select that. You select the sketch plane you're going to sketch on it. You can also select a sketch plane that's a part of or select a plane like a face that's a part of a part. And we will do that in a minute. But first things first, we're going to go ahead and follow the instructions here. So it wants us to select the front plane to begin a sketch, and then create a 1 inch by 2 inch rectangle with a centered inner rectangle that is 0.05 inches smaller than it. So we're going to try different things until we get this. I will show you how to do it. It's not that complicated. What we'll do, first of all, we want to go to the top here. That way we can view normal to the sketch plane. And we're going to make a rectangle. So you can do this corner rectangle here, or you can do a center point rectangle, which I like to do if you want it centered about the origin here. The origin is the part where all three planes intersect. The origin. So, right, we can click this, drag it out, and now it's giving us a rectangle, right? We can choose where to put this extra point, and then if we click again, it'll, be there. And now if we move our mouse, we can change these dimensions that's been given, which is 1.627 inches by 2.86 inches. Doesn't really matter, that's just what we dragged it to. But if we go ahead and type a number there, like 2, and press enter, it'll change that to 2, right? And if we type 1 here, press enter, it'll change that to 1 inch. Now, I want to actually show you guys how to make dimensions from scratch. So we'll just, we'll start with this. And if you want to edit a dimension, you just double click. And Onshape, as a general rule, if you double click on anything, you can edit it, right? So if we double click on this dimension, we can change that to 3 inches if we want, or 3 plus 5 inches. We'll give us 8, or just 2, right? You can do all sorts of equations in Onshape, and it's really useful if you're trying to, calculate something like in the middle. You can just do the length. Like if I wanted to move something in the very middle here, I could say 2 divided by 2, right? That's going to give you the middle. Of course, you can just constrain it to this origin here. That's why I did the center point rectangle. That way everything is centered about the origin. It makes it just easier to do dimensioning-wise and configuration-wise, right? But yeah, we'll look at that in a minute. But first, we got to dimension this side, right? So right now, these are free to be dragged. These can be any size you want them to be. Now we're going to use something so that's not true. We're going to use this dimension tool. And again, if you're a gamer, you just press D for dimension, or you can just press this button up here and literally just, drag your cursor around and select this line. And then you drag out your dimension and click again, and it'll give you a little editing window where we can press 1 and enter. Additionally, if you want to, you can drag this around more, but if you want to edit it by double clicking, you can say 1 millimeter, and it will become 1 millimeter long, which is very small, right? And it'll give you a value in inches, but if you double click on it, it'll say millimeters. So you have your default unit for the workspace, but if you want to mix and match, you can. Onshape handles that pretty well. We'll go back to 1. And now what's the second part of this assignment? We want to make a centered inner rectangle that's 0.05 inches smaller than it. So we can do this 2 different ways, and I will show you both ways. First thing we can use is the offset tool. So we click this offset tool, and we wait for our cursor to show up just because my internet's slow right now. And we click this, and we click this, and we click this, and we click this. And we click all the lines we want to offset. And then we can change this because it wants to be a centered inner rectangle. Keyword here, inner rectangle, right? So it has to be on the inside. So we're going to click this so that it reverses directions. And then I can change this dimension, right? I can change this dimension here to be 0.05. And that'll make it exactly what I want it to be. But, you know, I don't really want it to be like that. Let's go ahead and change that. We'll just go ahead and press Ctrl Z to undo, or you can just press undo up here. And that's going to get rid of this offset that we just made. How I'm going to do it, because it's a little bit more useful to show, is making another center point rectangle centered about the origin, and dragging it out to about right here, and then using the dimension tool to constrain it to be, nope, not that, to constrain it to be 0.05 inches away from each wall. And because it's a center point rectangle, it's always going to be centered right here, so you only have to dimension 2 of these sides, right? Whereas if you did a corner rectangle, like this, from the corner here, you would have to dimension it to all the sides because it won't automatically be symmetrical about this plane here, about this axis here, the y-axis. We'll go ahead and press Ctrl Z and delete that. And we're good to go, right? We've made ourselves a little thingy, right? So what does it want us to do next? All right, well, create a sketch, right? Exit the sketch and extrude the outer rectangle to 10 inches. All right, so what does any of that mean? Let's find out. Okay, so first of all, extrude, right? If you're a gamer, again, you just press Shift E. That basically gives a sketch a third dimension. All right, gives a sketch a third dimension. All of these do that, but extrude is the most basic, and it literally just makes it go up. So we'll click extrude here, and we will click this rectangle face here, right? And it'll make it go up. You can see, right? It's made that outer rectangle. If we click the inner rectangle, it will make that go up. If we unclick the outer rectangle just by clicking it again, it will not select that. If we click that again and click the inner rectangle, right, it will just make that a whole thing. Also, you can just go ahead here and click the sketch. And it'll pick the whole sketch. It'll sort of choose what you want the sketch, or what parts of the sketch you want to extrude, and it usually gets it right. Sometimes if you had like a hole in here, you know, or if you had like another piece of geometry, it might not get it, so you might just have to manually add that. Right, but you don't always need to do that. And then if you want to change the direction, you can go like that, right? And then you've got these different options here, which we won't get into just now, but we will in a minute. So right now, right, it wants us to be 10 inches long. So right now, we have all these different options for extrusion for end conditions. We don't care about any of these. We really don't. We're just going to pick blind, which means it blindly follows a dimension. And we're going to give it 10 inches. All right, 10 inches. And it's going to make it 10 inches tall. What do you know? Okay. Or you can make it 8 inches. Or 8 minus 1. But we'll just go with 10, right? We'll just go with 10. You could also do 10 divided by 2, which would give you 5. Or you could just do 10. We'll just stick with 10 for now. And we'll make a check mark here. And let's see what it wants us to do next. We can go ahead and hide all of these sketch planes just so that they're not really in the way. We'll keep the origin though. Right. So now we've got our part. What does it want us to do next? All right. It says make a 1-inch circle on the 2-inch face of the part with its center in the middle of the part in the Z direction, and it's 3 inches away from the other side in the Y direction. Okay, so first we're going to make a sketch, right? Click sketch up here, and now's the part where we're going to select a sketch plane that is not some of the starting geometry, right? It's going to be this here. If there's a flat face, you can make a sketch on it as a general rule. All right, so we're going to view normal to that. Alternatively, you can just right-click and say view normal to sketch plane, and it will do the same thing. But if you want to use this, I usually do. That makes it a lot simpler. You just click on a thing, and it takes you to where you want to go. You can also press F, and it'll zoom to fit. Or you can just right-click and say zoom to fit. Right? Right-click and say zoom to fit. So yeah. All right, it's asking us to make a circle. So let's do that. Right, click circle up here, center point circle. There's other ways you can make circles, but center point circle makes the most sense. And we'll start it. See, right here, it's giving us the center line of this. So this is going to be a vertical constraint here. Constraints are things that give a sketch rules. But yeah, it's going to be a vertical constraint, but we don't really want that. Right, we'll dimension that ourselves. So we'll start here, and we'll move it out, and we'll give it a dimension. All right, we'll give it a dimension of 1 inch. Okay, not that complex, 1 inch. Now we're going to do some more dimensions. Maybe I should plug in my computer there, but we're doing some more dimensions. And we'll go to the top here. We'll dimension it from the top here. We'll dimension it 3 inches down, like it wants us to. All right, and now we've got to dimension it so that it's halfway in between. So let's see how long this is, right? I just pressed escape so that it wouldn't give me a dimension, because you can just click on stuff in Onshape and it'll tell you its dimensions. If you click here, it's going to give you measurement info about it. So that's 2 inches long, right? So what do we want to do? We want to make this centered, so we're going to make it 2 inches divided by 2, which is just 1. We could do that math in our head, but showing it on the CAD is important, or whatever. Dimension here to the center point there, and to here, right? And we'll make that 1, or we'll make it 2 over 2, right? Which is just going to give us 1. And that's going to put it right in the center. Alternatively, you could delete that dimension, and you could go up here to constraints, and you could say vertical, which means it's going to be on the same vertical line as the other thing that you choose. So we'll click the center point of this circle, and we can click the center point of this line if we wanted to, or we could actually just click the origin, and it'll make it vertical with that. And because we centered everything about the origin, it'll make it vertical there. So now if we try to move that, it's going to say it's got this vertical constraint. If we delete that constraint, just by clicking it and pressing backspace, we can now move it left to right. It won't move up and down because we've dimensioned it that way, but we can move it left to right as much as we want. You see it's going to snap here to above the origin as well. So that's also an option. But we don't want that constraint. We'll just do a dimension, so we'll delete that constraint. It's effectively the same, but I think the constraint is a little bit harder to change in the future, you know. So we'll go here, right, and we'll go here, and it's 1, right, it's 1 already. Okay, so now we have our circle, right, that's pretty exciting, pretty cool. So now we're going to do another extrude, but this time we're going to remove material with the extrusion, right, so if we click on this, it's going to create a peg, and we don't want a peg, all right, we want something that removes. So if we click this, it'll go in, but we'll leave it as is for now, right? We're going to go up here to these tabs here, and instead of adding, we can also have it create a new part, which is going to make a second part in this part studio. Right, it becomes a different color there. You can add it as well. Because it's touching, it will merge. Or you can have it remove, and it's automatically going to, no, you'll have to flip the direction there. It may automatically flip the direction if you haven't touched the direction before. We'll click this. You can also click this, and it'll do the same thing. All right, and this is going all the way through, right? Because it's set automatically to blindly follow 1 inch, it's going all the way through. You could make that longer, like 2 inches, and it won't do anything different, right? Well, it will. It'll go farther. You can also drag this. Which, you know, isn't as dimensionally accurate, but if you want to just drag it past everything, so just that it goes through, you can. What I'm going to do is I'm going to click here, go to the end conditions, and select through all, right? And that's just going to make it go through everything, indefinitely, which is usually what you want to go for. You could also have it go up to face and select this face, right? So that'll make it go exactly to here. If you have something right behind this that you don't want to, like if this part goes right here, or like comes around, if you have something right behind this that you don't want to be touched, you can just have it go up to the face, but I'm just going to say go through all, all right? And we'll click check there, and now we've got a hole. All right, that's our first part. It's as simple as that, all right? As simple as that. If we want to, go ahead and rename this sketch. We'll say boss base, we'll call it. And then we can name this sketch hole. All right, we'll name that hole. And if we want to go back here and edit hole, we can make it, instead of 2 inches, we can make it 1 inch from the top. Now it's a little bit more symmetrical. And you know what? Let's go ahead and make our first extrusion. Let's make it 8 inches. We don't want it to be 10 inches. We want it to be a little bit shorter. Okay. So now we've got our first part. I think that looks pretty good. And yeah, that's basically all you need to be able to do in CAD for now. Other things that may be important to know about, you can make folders within your documents, which are super useful. So if you want to have your main assembly here, and then the parts that go in that assembly in a folder, like, titled assembly parts or something, you can do that, which is really, really useful. You can also import stuff, which we will get into in the next lesson. All right, but yeah, that's effectively it. So let's go ahead and talk about a little bit what we learned, right? Parts for robotics and many parts that you're going to be making in CAD are not that complex, right? They're just materials with holes drilled in them to mount other parts. So they're generally modified parts that the team can buy, right? Which is called common off-the-shelf, or COTS for short. But yeah, parts are generally modified parts that the team can buy, and you can usually download CAD files for those online, which we'll do next lesson. So CAD really should be the tool to translate that design in your head right into a format other people can read, so no need to make things super, super complicated, right? I mean, you can, but like sketches, CAD should embody real life, so if you can't make it in real life, then you shouldn't really make it in CAD. Although that doesn't, that changes like if you're making concepts or stuff, but usually a good designer designs within their manufacturing limits. And that is pretty applicable to robotics because, you're going to be designing for parts that are actually going to be on the robot if you're doing design during the build season. If not, it's still really the same because, you want to design with construction in mind. So sketches don't really need to be super complicated, right? Right there, we just made one rectangle and then one hole. So if we had wanted to make 2 holes, we probably would have made another sketch for that second hole, unless the holes did the same thing. So if the holes were both like bearing holes or something, right, to put a bearing through, then we would make them in the same sketch probably. But if you had bearing holes and then holes to maybe mount a motor or something, right, a bearing is something that you put a shaft through and then it allows it to spin freely. But if you also had holes to mount a motor, you'd probably make those in a new sketch. That way if you wanted to go back and edit them, you could do that. And you could, go back and edit them without everything sort of falling apart. And having that, being able to change your CAD and make design changes as you go through the process, like having CAD that's adaptable like that is a sign of somebody who's proficient in CAD, somebody who's good at CAD. And also, there's no better way to learn a skill than to just put time in. So all of you, I really highly encourage you to just spend time playing around with the software and try to familiarize yourself with its features. There's plenty of online tutorials out there, including this series. And we will get into, all the concepts you're going to need for robotics CAD over the next few lessons. But yeah, so really the best way to learn the skill is to have time and practice and experience. The best way to learn CAD is to do design in it, or to embody designs in it. So, and we will be getting into that. We'll be doing practical design projects there. But like, I don't know, if you have a project around the house, like you want to, I don't know, build something for your desk, or I don't know, I can't really think of many applicable projects that, the average person would be doing. But if you have a hobby or something, just try making CAD models for it. That's a really good way to do it. Use dimensions, measure the things in real life, and then base your CAD model off of that. And then maybe build the thing that's in the CAD right afterwards. That's the best way to learn. I mean, the way I learned CAD was doing CAD for a robot, not because the robotics team wanted me to, but because I was bored and it was the summer. It do be like that sometimes, but yeah. Yeah, so really, like, I had, very limited knowledge of CAD. After I did that, spent a lot of time just putting in the hours and learning and practicing. I was really proficient at CAD after I left that. And I had been a good designer throughout, right? I was able to, sort of think of these concepts and apply them to a practical thing, right? I was able to draw things on graph paper that made sense, but then I wasn't really able to translate that into the CAD as seamlessly as I would have liked. So I just, put in a ton of time and figured it out. CAD is not that complex. If you spend the time, you will learn how to do it well. And that's what we're going to try to facilitate in this series. So yeah, thank you all. As always, if you have questions, put them in the comments or email me. And yeah, thank you so much for watching. Right, and oh yeah, right, we're only exploring the basics of CAD so far. Right, so we sort of phase shifted between what we were doing in the beginning of the unit and the beginning of the curriculum, which was talking about practical design, like different parts that are applicable and different assemblies that are applicable. And now we're just talking about basic CAD. And we will get into sort of merging the two as we go to the end of this CAD unit, and then as we'll like the last unit, which is projects, which is practical design projects, is going to be really just like merging the two incredibly well, or incredibly, comprehensively, which will allow you to sort of get a feeling for how practical design works. But yeah, as always, thank you for watching, and I'll see you all guys in the next lesson. Bye.